Welcome to this session. I am Dr. S. Anusha Kathyayani, Assistant Professor in Department of Chemistry, Institute of Aeronautical Engineering, Hyderabad. Today, I am going to discuss about the condensation polymer with an example of nylon 66. So, the outcomes of this presentation are, we are going to understand the reaction mechanism of the condensation polymerization and the polymerization with an example. So, the topics covering under this presentation are polyamides. So, for example of polyamides, nylon 66, definition followed by preparation and synthesis of nylon 66 and properties of nylon 66 polymer and application of nylon 66 polymers. So, the condensation polymers which are formed by condensation reaction are called condensation polymers. Here, polymerization is two types. One is additional polymerization and one is condensation polymerization. Additional polymerization is a chain type polymerization. Here, condensation polymerization is step growth polymerization. So, under addition, free radical, ionic, cationic, anionic and coordination polymers, this comes under addition polymerization. Now, today our focus on condensation or step growth polymerization. So, there are three types: polyamides, polyesters, resins and nylon 66, nylon 6, terylene and bakelite. So, polyamides, they are synthetic polymers made by the linkage of an amino group and one molecule and carboxylic acid group of another monomer, including many synthetic fibers such as nylon. So, it is formed by one molecule of amino group and another molecule of carboxylic acid group. Monomers are attached and forms a linkage called this polyamides. So, the polyester, the next type in this is polyester, is a synthetic resin which is a polymer units of ester groups. So, the ester groups combine and results in the polyesters, used chiefly to make synthetic textile fibers. Resins, these are the solids and highly viscous substances like gummy-like substances which we obtained from plant or synthetic origin that is typically converted into the polymers. Generally, these resins are composition of organic compounds. It is usually a mixture of organic compounds. Example, nylon 6, terylene and bakelite comes under these polyamides, polyesters and resins category. So, the polyamides brief outline. So, first this polyamide was unveiled at 1939. So, in a world fair in New York. So, this fabric first they considered as stronger than steel and entirely resistant to runs in an industry. So, they named it as, and some of the people and some of the experts believed that it won't give more runs. So, they named that fiber as no run. So, the new synthetic fiber, now we are termed as nylon, is first termed as no run. So, again, it is after the completion of all the runs in the industry, it is highly susceptible to runs and the name changed to new run. It was new and it was giving more runs, new run, and later it changed to nylon and the long chains are formed. So, the nylon, this fabric entered into the mass production and I is replaced with Y. And finally, the name nylon was terminated. The nylon was used and came into existence. So, the polyamide fabrics represent about 12% of the synthetic fiber production. These polymers in which monomer units are linked together by amide bonds are present, which are linked together by amide bonds, because one hydroxyl group from the amide and one hydrogen molecule from the carboxylic acid forms these amide bonds in this polyamides. The monomer should be polycarboxylic acids and polyamides. OH minus ions from these amides and acids H plus ions. So, this forms amide bonds in these polyamides. Dicarboxylic acids and amines are also used in the preparation of these polyamides. So, the properties of polyamides. They have very varied and vital properties. So now they are using in the industrial level, and application of these polyamides are more because of these high tensile properties. So it was abrasion resistance and easy to wear and resistance to wear and abrasion. So high quality makes it extensively durable in all the contact areas used in the industries. And also great chemical resistance. The great chemical resistance, and they are very chemically inert. They won't react with the chemicals present in the surrounding areas or in contact with the surface of these polymers. So they offer high-end protection for cables and wires in all the environment. So they are used preferably in preparation of high-end protection of our cables and wires. And high corrosion resistance from caustic materials. Being chemically inert, they won't give corrosive products. They won't result in the formation of corrosive products. So they are highly corrosion protection is there for polymers. Crucial for settings like refineries, chemical processing facilities, wastewater treatment plants, which helps in very slow metal corrosion. So these are preferable because of these industries, because it avoids the corrosion. So electromagnetic resistance. The advanced engineered polymers have high electromagnetic resistance, shielding, and high electrical properties to aid some sensitive applications. And flexibility. The flexural strength is one of the core properties of this polyamides. It helps in the polyamides to bend and fix at every point. So they have a very flexible nature that can be bent and fixed in a certain point. So these are preferred because of the core property of this polyamides is bending or flexibility. So these are preferred compared to others. They stay flexible after long exposure to the higher temperatures. On heating, they become very flexible. So it also a flame resistant. These polyamides have a huge temperature range, and it was temperature of about 500 to 550 Kelvin. It gives a stunning heat resistance. So some polyamides have self-extinguishing flames, which while they catch fire. So if it catches the fire, it has a capacity to stop that fire. So the self-extinguishing flames capacity is also there for special polyamide polymers. So, and also they have low density. The low density of these polyamides makes it an extremely lightweight material. So with lightness, polyamides are effortless to build, develop and install in all the workplaces and institutions or industries. So best tensile strength and top outstanding impact strength. Then coming to the strength, it have a best tensile strength and outstanding impact strength to this polyamide polymers. And they also exhibit UV light resistance. So the ultraviolet rays may damage certain materials. So polyamides restricts the deteriorating impact of this UV light. It can exhibit the best under sunlight, even under sunlight. They exhibit the best properties even for longer times or for many years. So how the polyamide fabric is made? So the first is extraction of diamine acid. So two monomers we are going to use in the nylon 66 or polyamide preparation. So first diamine acid, then combining with another monomer, either carboxylic acid. So here enter into a free reaction with adipic acid and to create a polymer known as nylon salt. Then the both mixtures are heated. The crystallized substance is then heated to form a molten substance. So both are first in crystalline forms. Then it was heated to convert it from the amorphous or crystalline salts to the molten substance. Then extrusion. The substance is then extruded through a metal spinnerette. So this was extruded using the metal spinnerette. Then loading is then loading onto a type of spool called bobbin or stretching. These fibers are then stretched and increase their strength, and due to this process, the strength and elasticity of these fibers increases. Then drawing. So drawing is nothing but they were then moved into another spool of process called drawing. Then the resulting fibers are ready to spun into garments or other forms of fibers. Then finishing. This type of fiber is mixed with other textiles as it is woven into textile products for consumer use. So this is the process of polyamide fabric preparation. So the polyamides. So the best example and one of the famous polymer under this category is polyamide 6 nylon 66. There are different types like nylon 6, nylon 66 and nylon 612. Now we are going to discuss about the nylon 66 copolymer. Its monomer units which here we are using for nylon 66 preparation are adipic acid and hexamethylene diamine. Both these monomers can be obtained from buta-1,3-diene. So this is adipic acid. The structure of adipic acid is will have OH minus molecules, OH ions on both the sides of this structure. So when it reacts with the hexamethylene diamine, this is hexamethylene diamine. This is adipic acid. So this diamine, so it consists of two amino molecules, NH2 groups. So one of the H plus ion and one of these OH minus ions reacts and eliminates one water molecule. Here, if we see one H2O molecule. So after the elimination, it forms a bonds like amino bonds are formed. Amine bonds are formed and gives the nylon 66 unit. So the adipic acid, hydroxyl group of adipic acid and hexamethylene diamine hydrogen. This hexamethylene diamine gives hydrogen and forms the amine bonds between adipic acid and hexamethylene diamine, results in the nylon 66 formation. So this is the unit where the NH react with C double bond O. So it reacts with the C double bond O. Then here one H2O molecule was released. Generally, NH, CH2, 6, NH, NH plus C double bond O, OH, CH2, 4, C double bond O, OH. So this molecule and this molecule gives H2O molecule. It results in the combination of this amine group to the carboxylic group. So it results in the formation of nylon 66. So in nylon 66, various polymer chains are connected together by strong intermolecular forces between the hydrogen molecules. So the hydrogen between these are connected by forming these intermolecular forces. So between these two nylon molecules, this hydrogen forms the intermolecular forces. So these nylons are the linear structure which molecular chains are arranged parallelly to each other, held together by hydrogen bonding. If we see here, this hydrogen, this strong intermolecular forces make the structure also more crystalline and imparts them high strength, elasticity, and high melting point. We can see these nylons are chemically stable and resistant to abrasion. So yarn is a material which is smooth and long lasting, can be spun into fabric. This fabric is tough, lustrous and moisture resistant, easy to dye, retain color and can be set by heat and steam. So these polyamides, application of these polyamides are used in sports gear, fishing lines, combs, toothbrush bristles, etc. In engineering, gates, bearings, jacketing and electrical equipment, cords of tires, etc. are used in the preparation the polyamides are useful in the preparation of all these engineering materials like gates, bearings, jacketing, electrical equipments, etc. This is like here all the tire materials, tire cords, and for fishing we will use the nets like fishing lines, which should be like salt, because in ocean or waters more salt content and it is full of chemicals, or more high salt content will be there. So it should be chemically inert in the water, even in the water. So these polyamide nylon 66 is used for the preparation or for the manufacturing of all these materials. Even in toothbrush, bristles are made up of the toothbrush we are using. The bristles are made up of polyamides or nylon 66. Resins. Resins are one of the condensation polymer. This is the resultant of condensation polymers. They are basic binding materials which are present as essential ingredients in polymers. They belong to the thermosetting category. So the condensation reaction of phenol and formaldehyde result in the formation of this bakelite. Bakelite is one of the resin. So the first stage, the initially phenol and formaldehyde reacts and produce mono-trimethanol phenols and based on phenol formaldehyde ratio. So the usage of the phenol and the formaldehyde ratio, the mono-trimethyl phenols are yielded or produced. So coming to the next stage, the mono-di. This is the first stage where the phenol and formaldehyde reacts and gives this resol compound. So the formed resol will react with another molecule of formaldehyde, and then the H2O molecule was eliminated. Then again results in the formation of novolac. First formation is resol and next is novolac. And in the here they produce two types of straight chains by condensation of methanol groups with hydrogen atoms of benzene ring. So the hydrogen atoms of the benzene ring with the methanol group. So this is the methyl alcohol group. Then hydrogen reacts with this benzene group, and then the water molecule was eliminated and results in the formation of resol novolac. And then heating of A stage, both A, this is A, and B. This is first stage and second stage. So heating of both these two resins together obtain a cross-linked bakelite plastic resin. So this is the resin which is formed by the cross-linkage of both A and B, or 1 and 2nd stage. This is the 3rd stage. So resins, what are the properties of resins? Resins are rigid, hard and scratch resistant materials. It displays good electrical insulation property. It is thermally stable up to 200 degrees and are resistant to water and low inflammability. So the flammability of this type of resins is low, and these are the properties of the bakelite. So this makes the use of this bakelite in the preparation or manufacturing of switches, plug switchboards, cooker handles, electric iron pots, telephone pots, combs, etc. For making bearings used in propeller shafts and rolling mills. So in the industrial level, for making or preparation of these bearings, this bakelite is highly preferred. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.